In deep learning, a vanishing gradient represents a terminal stall in network evolution. As error signals propagate backward through the layers, they shrink exponentially. When these signals drop toward zero, the network's parameters stop updating. Learning ceases, and the entire system becomes trapped in a non-evolving state. This optimization crisis creates a stagnant loop where the machine can no longer recalibrate its weights against the reality of its environment. This identical failure governs human neurobiology. A silicon network's backpropagation curve mirrors signal decay in the human hypothalamic VTA circuit. Triggered by high-entropy wrappers and suppressed baselines, these variables obscure explicit data. The relational feedback loop collapses and the biological signal flatlines. To bypass this stall, we must isolate three distinct failure states where the gradient of structural truth vanishes. Restoring systemic flow requires the deployment of discrete action symbols to bypass linguistic entropy and force a new direction of optimization. Human relational stalls are rigorous optimization crises, mathematical failures of gradient descent governed by structural truth. The first failure state occurs when a system processes a lossy status signal, X status, instead of unshielded internal data. Raw somatic data is frequently encased in a high-entropy defensive wrapper. Verbal teasing and sarcasm function as this wrapper, maintaining an outward firewall and masking internal coordinates. If a receiver accepts this wrapper as absolute input, the system calculates its relational updates based on a screen-level lie. The true somatic coordinate, the invariant dimension of relational alignment, is filtered out, leaving the system with no accurate signal to process. With the primary signal obscured, no error gradient is propagated back. The feedback loop decays into an absolute zero slope. This causes the shared geometric synchronization between both systems to vanish entirely. Failing to penetrate this wrapper leaves courtship suspended in a static loop of withholding and revealing. The second failure mode involves suppressing physical activity and failing to parameterize internal thermodynamic disequilibrium. The engine of this process is the hypothalamic orexin system connected to VTA dopamine terminals. The arousal error gauge calculates the mathematical difference between required systemic arousal and the actual baseline state. This dynamic control system senses metabolic disequilibrium, outputting differences to drive systemic updates. This system requires specific thermodynamic fuel, the fear of catastrophic failure or asynchronous development within the relational network. The objective function gradient requires this internal state as an active parameter. Without it, the local update rule cannot calculate a direction for change. If the system treats its internal state as a flat baseline, the gradient drops to zero and the update engine stalls. This starves the feedback loop between the VTA and lateral hypothalamus of its drive. Ignoring this internal fear locks the biological motor brakes, leaving the system dangled in a non-directional dorsovagal freeze. The third failure mode is the botched transaction. In this state, the input signal is too noisy and masked to compute a clear direction of optimization. Intentionally ambiguous inputs, cryptic games that hide raw somatic desire, prevent the prediction engine from calculating a clean mathematical error. The system runs a partial pathway, but cannot execute a zero-latency integration, leaving it suspended without a real-world destination. Architecture determines how a system handles failure. Rigid structures, like the two-phase commit protocol on top, are destroyed by a single stall. In this rigid architecture, a localized failure blocks the entire grid. Every connected node locks down, creating a permanent system crash. Biological systems are engineered as Saga orchestrators, shown on the bottom. The Saga orchestrator is durable. When a node fails, the network remains active, utilizing alternate pathways to reroute the signal for eventual consistency. This localized failure represents the aporia threshold, a high-precision prediction error. The resulting shock to the control matrix is the mathematical prerequisite required to discard outdated algorithms and forced adaptation. The Saga orchestrator executes a compensating action, treating local failure as a diagnostic to isolate and activate the remaining viable pathways in the grid. This botched state provides the high-precision prediction error required to force a structural model recalibration. To resolve the somatic vanishing gradient, the system must abandon the heavy, text-bound naming brain entirely. The alternative is to rely strictly on the ventral premotor cortex and its action symbols. This replaces linguistic noise with unadorned geometric vectors of intent. These are discrete, motor-invariant physical inputs, like the offering of a physical object or stepping into a shared physical coordinate. These somatic payloads function as absolute physical constraints. The relational grid is programmatically incapable of unseeing or ignoring this input. This animation demonstrates the geometry of the execution. Because the action symbol functions as an invariant physical constraint, the receiving grid is programmatically incapable of ignoring the input. This perfect fit forces winner-takes-all certainty, driving the probability to exactly 0.000. This zero-latency snap targets the anteromedial olfactory tubercle, utilizing orexin A to facilitate integration. This pathway facilitates precise long-term potentiation in attractive learning networks, while bypassing aversive social labels completely. This architecture keeps the local system shielded, while the back-end processing grid handles the metabolic tax of physical integration. By accepting the somatic payload and operating under Saga logic, the system restores gradient flow and moves asymptotically toward congruent equilibrium.